Hello, dear viewers. Today, we are going to take a detailed look at one of the greatest mysteries in the universe, the Fermi Paradox, and why we have yet to find other intelligent life forms in space. If you're ready, let's begin this exciting and profound journey of discovery. To understand the size of the universe, let's look at some numbers. In the Milky Way galaxy alone, there are between 100 and 400 billion stars. About 20% of these stars, 50 billion of them, are sun-like stars. Moreover, these stars are very likely to be surrounded by rocky planets. Assuming that, on average, there are 5 planets around each sun-like star, there are billions of potentially habitable planets in the Milky Way alone. However, the universe is not just the Milky Way. There are at least 100 billion galaxies in the observable universe, and probably more than 300 billion. When we include dwarf galaxies, this number rises to 78 trillion. Even dwarf galaxies contain billions of stars. This enormous number strengthens the idea that life must be widespread in the universe. The Fermi Paradox. Where is everyone? In the 1950s, the famous physicist Enrico Fermi asked the question, where is everybody? Statistically speaking, the universe should be teeming with life. However, to date, we have not found even the slightest trace of extraterrestrial life. This is known as the Fermi Paradox. The Great Filter Hypothesis. One of the most popular explanations for the Fermi Paradox is the Great Filter Hypothesis. The Great Filter can be thought of as a large barrier that prevents life from evolving from simple chemical molecules into intelligent civilizations. This filter can come into play at any stage of evolution and prevent life from progressing to more advanced stages. Abiogenesis. Perhaps the emergence of life, abiogenesis, is a very rare event. Even if there are billions of Earth-like planets, abiogenesis is so unlikely that life could have started on only a few planets. It is not enough for life to begin. The evolution of eukaryotic cells is necessary for complex organisms to form. This process can be extremely complex and rare. The evolution of intelligent life also presents many challenges. As humans, we have many cognitive and psychological weaknesses. These weaknesses can lead to the self-destruction of civilizations. In nature, there is a constant selection pressure to build large and complex structures. However, this pressure also applies on a cosmic scale. Perhaps many civilizations have been destroyed by natural disasters, wars, or other destructive events. Another possibility is that civilizations avoid communicating with each other. Alien civilizations may have closed in on themselves, fearing contact with other potentially dangerous civilizations. According to this hypothesis, civilizations hide from each other in the universe. Each civilization sees the others as a potential threat, and therefore prefers to remain silent. This makes the universe look like a dark and silent forest. Advanced civilizations may be using different types of signals, and we may not have the technology to detect them. We listen to radio signals, but other frequencies or types of waves could also be used. Evolutionary timeline. It takes quite a long time for life to become widespread in the universe. In the 13.7 billion year history of the universe, there may not have been enough time for civilizations to evolve and discover each other. Material and energy constraints. Advanced civilizations need vast amounts of materials and energy to spread to every corner of the universe. When these resources are limited, civilizations can only be confined to their home planets or their immediate surroundings. The Zoo Hypothesis. According to this hypothesis, advanced civilizations avoid contact with primitive civilizations in order to monitor their natural development. Just as humans watch animals in zoos, aliens could be watching us. Simulation theory. Perhaps we are living in a simulation of an advanced civilization. In that case, it would make sense that there are no other intelligent life forms in the universe. Conclusion. The Fermi Paradox offers many interesting hypotheses to explain why life in the universe seems so rare. However, we need more data to come to a final conclusion. Therefore, we must continue to explore space and look for traces of life. As Arthur C. Clarke said, there are two possibilities: either we are alone in the universe or we are not. Both possibilities are equally frightening. See you in the next video. Bye.